Good morning, everybody. Another nice Friday morning to start off rounds. I want to thank everybody for coming. So today is going to be a real treat. We have Dr. Yang going to speak to us. We are very proud of Dr. Yang in the Division of Neurosurgery. He's been working with us now for about 4 years and has been doing incredible stuff, which he's going to show you. To give you a little bit of background on Dr. Yang, he did an engineering degree, and after his engineering degree decided he wanted to go into medical school. But medical school wasn't hard enough, so he did an MD and PhD at the same time. When he finished his MD and PhD, he went into neurosurgery with the MD component, which is what most people would do. But then in addition to that, he became a professor of engineering and physics in Ryerson University at the same time. While he was a neurosurgery resident, which for most of us, we barely had time to go to the washroom, he was able to build up a lab and teach and be a full professor at Ryerson with a lab Tier 2 Canada Research Chair, millions of dollars in grants, and I think somewhere between 15 and 20 patents. When he finished his neurosurgery residency, he did a fellowship in endovascular aneurysm repair, stroke care, etc., and we recruited him here at Sunnybrook. Since he's been at Sunnybrook, he's done amazing things. You guys all know what's going on in OR8 and this futuristic operating room. Additionally, he has he's associated with a company that is commercializing many of the ideas that he's brought, not only from idea stage to trial stage to patent stage, all the way to where you actually can use it on patients, which is a long, long course. Normally, when people present their research at these meetings or in this forum, a lot of data is presented, a lot of new ideas, etc. If we asked Victor to do that, he could probably stand here for 7 days and just keep talking about all the great stuff he's doing. But instead, we wanted him to focus on something that most of us know nothing about as physicians and nurses. How to take an idea, a research proposal that can possibly change lives, improve people's outcomes, etc., and take that all the way from the idea stage to the commercialization stage, something that most of us know nothing about. So I want everybody to welcome Victor. We're looking forward to his talk. It's going to be a very interesting morning, and I'm sure it's going to stimulate lots of questions. Thanks.
Thank you so much. Thanks so much. So I was asked by Dr. Avery Nathan and Dr. Todd Mainprice to talk about commercialization in the context of surgical innovation. So Todd and Avery, they recruited me to Sunnybrook and gave me this opportunity to do what I absolutely love to do. So I think it's important to understand that all surgeons are innovators. All surgeons innovate. Everyone here, all the surgeons in the audience here. We all have our particular ways to do things that we thought our patients would benefit the most. And Dr. Fazal here, he taught me, and I think many other residents, a lot of particular things. He has been a great mentor. And we learn these things and try to help our patients. But one thing we have to remember, though, is that as a single surgeon, the number of patients' lives that we can impact on is mathematically limited. Let's say we operate, a single surgeon, let's say we operate on 400 patients a year. I think that's probably the practical limit. And let's say we have a 50-year of surgeon's career. Then we can only help 20,000 patients. But engineers work in a different way. The bridges we build can help millions of people to cross it. Engineers build tools. And when you build tools, the tools are like amplifiers, because there are many, many users. So then they can amplify the impact to many, many patients. So if we combine the attributes of surgeons and engineers, then you will have surgeon innovators, like Dr. Oli Antonishin, like Dr. Mark Jeske, and many others in the audience here today. I have to say, I'm very, very proud to work in this hospital with all of you here. And in this hospital, I have to say that we never have enough beds. We don't have enough beds. We don't have enough resources, right? But what we never lack, what we are never short of, are ideas. And we always have the same stubborn determination that we want to help our patients. Because we know we have to be cheaper, we have to be faster, and we have to be better. So that is why we innovate, we design. But designing medical tools is just not enough. We must also mass produce like the engineers. So we can deliver them to the other surgeons, and then they are users, and they can help us to help more patients, right? If we don't do that, then we can never scale up. And then the innovation will just die in a research lab. It will just be a pretty theory. But we are surgeons here. We're not theory people. We're crazy enough that we just want to act and actually do it, right? So Avery and Todd asked me, so how do you achieve that? So I think there are many ways towards mass production. And one way is to pass our existing ideas to existing large companies. And sometimes they listen. So I'll give you an example. So over the past 5 years, we started treating patients with massive strokes, right? And then here, this is one of the stents called a Trevo stent. This is where there are earlier incarnations. So in our hospital, the initial volume about 5 years ago was 5 patients per year, and now we are treating about 100 patients per year. The initial stent has a soft tip, what I'm showing you there on the right-hand side. But at that tip junction, there was about 1 millimeter that is actually rigid. So if you push that stent against the bifurcation of the middle cerebral artery, there's a theoretical risk that you can perforate the middle cerebral artery. And patients with strokes, they are on TPA. So that is a major risk of hemorrhage and it can be fatal. So during the early clinical use, when we did that in our angio suite here, I asked Stryker, I said, you need to get rid of that. You need to get rid of that. And I'm sure I was not the only user providing such feedback. I also give similar feedback on a different aspect to Medtronic as well, and then to ask them to add radio opaque markers to their stent so we can see the stent during stroke treatment. So now these stents have been used to treat thousands, probably hundreds of thousands of patients now over the past 5 years when multiple clinical trials showed positive results. So these are incremental improvements. And we give these incremental feedback to the large companies for free because we care. We care for our patients. But sometimes a disruptive idea comes by and the large companies don't listen. It's not that they don't want to. They just can't listen to it. Why is that? Because they are locked in the status quo of a value chain system. From the equipment manufacturer to the sales channel, all the way to the user, and finally the institutions and the patients, right? There's too much inertia in that entire chain, all the people, all the value that's locked in there for the large companies to change. So take spinal surgical navigation as an example. There are no lack of published literature to show that this improves patient outcome and reduces complications. But there are many problems that leaves 85% of the patients who are actually eligible for spinal navigation during their surgery, but they don't have access to such clinical care. Why is that? The large companies want to make and sell intraoperative scanners that's coupled with the navigation station. Because they are higher margin, the scanners are more higher margin. There's high-end equipment. And then the capital sales distributors, the sales channels, they love large ticket items for commissions. So in today's healthcare budget environment, this means less market penetration of three-dimensional spinal surgical navigation, and less than 15% of the eligible patients can benefit from it, right? So these radiation-producing scanners, they also interrupt our workflow. And I think the nurses in the audience know, especially the radiation technologists in the audience know. And they also require the radiation technologists to operate them, so they need more manpower in the operating room. So when these large companies are locked in the status quo value chain, they don't want to change. They don't listen. In fact, they actually want to make it even harder. So what they do is that they're introducing robots. But the type of robots they design are actually no more than just a mechanical navigation device, just like the frame that we're using for neurosurgery. So the robot on the right-hand side serves the same thing. It's a mechanical navigation device. And this now costs more than $1 million. This is classical. In business school, this is called going up market, where there's higher margin than existing value chain. This is also the perfect storm for a disruptive idea. So Clayton Christensen, he's from the Harvard Business School, and he has studied this in detail, and many large companies failed at this because of disruptive ideas. He also defined what is a disruptive product. It must be one, cheaper, more convenient, faster, and maybe better. It also must convert non-users into new users, and it must have a new value chain. So let's look at this, right? A disruptive product comes along. It has to be cheaper, better, and faster. The technicians here know that it takes us 5 minutes, at best, probably 10 to 15 minutes to set up a CT scan like that. But why do we use that? Why don't we use modern technology? Modern technology that is cheaper and better. So here is the inside of a new iPhone. There are machine vision cameras in there. These are advanced technology. The only reason they are cheaper is because they're mass-produced for other markets. And I got to say that we're happy that we are a few years ahead of Apple in doing facial scanning using machine vision cameras. So our research team designed this. It takes intelligent algorithms to take binocular vision from machine vision camera as input, and they will mimic the anatomical judgment of a master surgeon, like Dr. Joe Finkelstein here. And they will match to a pre-operative CT or MRI scan. And this is convenient for surgeons and much faster. So I'll show you how fast it goes. So that's 12 seconds, right? And no other technology in the world can do that. So in our recent paper that's published in Scientific Reports by Nature Group, we show that the machine vision technology we have is 5 times faster than the Stryker navigation point matching technique, and 20 times faster than the Medtronic O-arm with a stealth station. What is more, that if you take into account the fact that the spine is a flexible organ, flexible organ. And the flexible organ means that the vertebral bodies actually move relative to each other, before surgery, during surgery, and after surgery. This is an important source of error propagation in all of the navigated spinal surgeries. And we are the first to solve this problem by using machine vision without using X-rays. And we solved it basically fundamentally in open spinal fusion procedures. And the other companies try to solve it using harmful radiation. So these are really revolutionary. These are revolutionary advances in spinal surgery. And we are awarded not only once, but twice Spine Technology Awards. And we also got a new product innovation award. These are not possible without the backing of our early investors. And some of them are here in the audience with us. With this investment, then we're able to scale up and find our talents, who work at 7D Surgical. Actually, have show of hands. The folks who work at 7D Surgical, hands up. Many of them are actually my lab trainees who joined the 7D Surgical. So they are the professional medical device developers. They're the manufacturers, they're the testers, they're the regulatory submission team, and they're also the clinical support team. And some of them you probably have met in the operating room here. They're joined by industry veterans. And the industry veterans really show us, guide us through how we get across so-called death valley for commercialization. I can also never forget the support from our patients who signed up to our clinical trials. So I want to tell you a story here today of a young lady. She fell from a building roof and sustained significant spinal trauma. She had leg weakness and bladder dysfunction. She was also 10 days from her wedding day. She was brave to be one of our early clinical trial patients. She had decompression and fixation of her spinal fracture. This is an MRI offer 4.5 years out. And Katie, she's here today with us. Thanks, Katie, for coming through the snow. And she didn't have to change her wedding day. She walked down the aisle on her own feet 10 days after surgery. Katie, we are indebted to you, to your trusting us, and actually bravery, I have to say, to help our future patients. And one of the future patients, he's also here today. Mr. Lee is here with his wife. He can't quite turn his neck. Yeah, please sit down. Thank you. Thank you so much for coming. Mr. Lee had occipital to cervical spinal fusion. I met him on Christmas Eve last year. He was diagnosed with renal cell carcinoma metastatic to the brain, to the lung, and to the spine. I've got to say, I didn't think he could be a surgical candidate. He was in pain. I was on call for the Christmas Eve time, and then I was off. He actually was in so much pain that he came back on New Year's Day again. And again, our colleagues saw him, and we didn't think we could operate. He went on to have radiation, chemotherapy, and then he had a car accident. Then he has excruciating neck pain. He was on escalating doses of pain medication, and eventually, even the continuous fentanyl pump could not manage his pain. He was ready to die. So we had no choice. We had to operate on him. And this took literally everything I know, all the capabilities that we have in this hospital. The endovascular embolization in the angio suite, radiofrequency ablation, and by the way, that's another innovation by Dr. Albert Yi in this hospital, and then 7D surgical navigation. So we were able to embolize the tumor blood supply partially, preserving the anterior spinal artery, showing the red arrow over there, for Mr. Li, so he can still have control of his limbs. We also did radiofrequency ablation, literally to cook the tumor intraoperatively. That was done with spinal navigation to further reduce the blood loss. So then we can cut into the tumor. So then finally, we were able to decompress the tumor and then perform occipital to cervical spinal fusion to reduce his neck pain. And all of that is done with the help from our anesthetist. All of that was done in one general anesthetic, one day. It was a long day for him and our entire team in the angio suite and at the operating room. And the total blood loss was 400 cc's. So Mr. Li now, he's 6 months after his surgery. He's off fentanyl, he's off his narcotic medications, and his tumor is further controlled by chemotherapy and radiation, stereotactic body radiation at our Odette Cancer Center. So these are just the tip of the iceberg of how much impact we can offer to our patients. We have the team, a very professional team. You can see they're coming from Brain Lab, Intuitive Surgical, Johnson & Johnson. With them, we can reach a larger patient population. With our advisors, who has been industry veterans, to show us how to get to a larger population base. And we are literally on the launch pad. You can see the accelerating numbers of pedicle screws that's inserted using our machine vision technology. Literally on the launch pad. That's SpaceX, by the way. I love this because I think this really signifies where we are right now. So, in serendipity, I think this is the first grand round we have after November 11th, right? So now I'm going to share with you something that's quite personal. I was raised by my grandma. She was a trained nurse in World War II. You can see that she's fashionable, even in 1944. She's one lucky lady because she worked in the same village where has a small airfield that Lieutenant Colonel Doolittle crash landed after his bomber raided Tokyo. The bomber actually never really made it to the airstrip because they took off early, they didn't have enough fuel. But the Japanese army did come to our village after that. She survived. She married my grandpa and endured the subsequent Chinese Civil War. She raised me in my youngest years. As my family was dispersed through the Cultural Revolution, The very first syringe I saw was her syringe. It was made of glass. It was carefully packaged in a metal box, and she lit alcohol cotton to re-sterilize it. I remember the flame. It was purely blue. She always tells me to listen to the nurses. And a few days ago, I went to see her. She was intubated in ICU. She still is. She was holding onto my hands tightly. And I told her what I do in this hospital. And the man and woman that I have the privilege to work with here. I told her that I do listen to our nurses, like Carolyn Johnson, like Sharon, like Becky, like Wendy DeTrani, Cheryl, Robert, who tells me to go faster. Less machines, that's what Robert said. Stephanie, in the middle of the night, Daryl Sparks, and many others. I told her about Abdul and the RPC team here, who re-sterilized the tools that we designed. All the nurses. I also told her about our Never Run project, which united all of our orthopedic spine and neurosurgery spine surgeons. This is on a fairly contentious topic, as you can see from the title. So it really takes all of you, all of our surgeon collaborators, colleagues, our nurses, our cleaners, RPC, PSPs, neuromonitoring team, the X-ray technicians, all of you, to raise our research group up. We cannot receive these awards without standing on your shoulders. Without you, without the support of all of our patients in the clinical trials, without our early investors who believed in our mission, 7D Surgical would just be a lonely soldier crossing the Death Valley, and a lot of companies died there. But because we are not alone, because we have all of your support, we can cross the ocean and plant a flag after the initial battles. We know this is not over yet. This is just the beginning of our disruptive navigation, winning the first few awards. We're going to scale up our impact, and we will help more patients. And the future is actually happening. For example, Dr. Kalfas, he's a visionary complex spine surgeon in Cleveland Clinic. That's actually the #1 site for 7D surgical navigation case volumes in the United States. We have Dr. Kamisa, who is the chief of spine service at the Hospital of Special Surgery in New York. We have Dr. Wing in New Hampshire, Dr. Tan in Virginia, Dr. Van Sickle in Denver. And let me add that Ernie Robles, they are at Denver ambulatory surgical centers. These are ambulatory surgical centers performing complex spinal surgery. So this is truly what Clayton Christensen calls a disruptive technology with a disruptively new value chain. This innovation, I have to say, belongs to all of you. All of us, the entire Department of Surgery team here. I think we should try to take a photo now because the clock is 9 o'clock. And we should try to have a photo taken from the front to have the whole audience, Doug, if that's okay. And I think our residents and the engineers to hold up that glass trophy, and with all of our surgeons together and our nurses to take a photo. Actually, there's one more thing I want to show you guys. No. There's one more thing I want to show you guys. So that's what's coming to OR8.